Greetings. My name is Ed Bauman, and I'm the Senior Program Manager for Trident Systems' Tactical Health Monitoring and Prognostics efforts. In this talk, I'll provide an overview of our Versatile Integrated Sensors for Towed Arrays, or VISTA technology, a self-contained data logger designed for the unique requirements of towed array and submarine environments consisting of multiple small modules that provide power, sensing, processing, and offload capabilities while operating for over 1 year without external power. As a small business operating out of Fairfax, Virginia, Trident has been delivering technology solutions for the warfighter since 1985. Comprised of 2 business units, Trident is uniquely positioned to provide both terrestrial and space-based solutions. The Space Electronic Systems Business Unit specializes in multidisciplinary, full lifecycle product design and support for custom spaceborne, software-defined radio applications, on orbit and failure-free since 2019. The Integrated C4I Business Unit is dedicated to the design, development, and deployment of innovative command and control systems for the safety and survivability of the warfighter and their assets. Within that unit, my team is focused on providing health monitoring solutions across ground, surface, and subsurface domains on both manned and unmanned platforms, from howitzers to submarines. Trident's ability to deliver quality products has been independently verified through both ISO and AS9100 certifications. While humanity has interacted with the ocean for centuries, only a small fraction has been explored and studied in detail, largely limited to areas near the coast and the surface. Limited sampling has been performed in more exotic areas, such as the depths at which submarines travel to perform their missions. Sunlight only penetrates to about 200 meters, which is less than the depth rating on most hulls. How can we accurately know the impact of the environmental forces on the sensors employed or the hull itself? Only a long-term collection of key operating parameters during the operations can provide a comprehensive view of the environmental impact on this equipment. Further, given the constrained mechanical space available, both within the array and aboard the ship, any data collection technology must be small and self-powered to ensure there is no impact to the other systems on board. While there is no current technology to address the lack of information on the operating environment, that does not mean it is out of reach. The Navy released topic N192-103 specifically to develop a solution to further enhance undersea operations and data collection. The topic parameters sought a solution that is field serviceable so it can be swapped out easily, self-contained so it can be inserted without impacting any other systems, and measures and records the environmental conditions experienced so it can provide an accurate representation and record of the environmental impact on the array. Further, the resulting technology must fit inside the mechanical and environmental requirements for a thin-line towed array and be able to be self-powered for at least 1 year. The resulting system will be inserted into a section of the array that is disconnected from the other power and sensor feeds to ensure there is no impact to the approvals or existing capabilities. As an independent module, the system can be swapped in and out as the Navy has need across key platforms and arrays. Trident's VISTA system is the solution for the underwater sensing and data logging requirements in a compact package. Internal sensors provide temperature, pressure, shock, vibration, and bending data collection throughout a deployment at a variable recording rate that adapts to the current usage profile. This data is collected directly from the onboard sensors, as well as synthesized internally through vibration and bending analysis to log and record the static and dynamic forces and external impacts. The flexible hardware architecture means that additional low-power sensors could be added in the future to the current design without a major hardware redesign. All of the collected data is stored internally in a compact binary format. Due to the data decimation techniques employed, the system is able to store millions of data points over the course of a year, which are exported once the module is back ashore. Mechanically, the system is built to meet the strict thin-line towed array requirements for length, diameter, and strength of design. All components are rated for the towed array environmental requirements, plus a design safety factor, and have been lab tested to nominal limits. Building for the most constrained use case ensures an easier transition to either fat-line arrays or direct integration onto unmanned underwater or remotely operated vehicles, both of which allow for larger electronics packages to be inserted. This novel combination of a battery chemistry designed for a long shelf life coupled with a low discharge current and aggressive duty cycling of the sensors and processing components, allow for prolonged operation well in excess of the required 12 months as measured in accelerated prototype lab testing. Once the array returns for a depot-level refurbishment, the data is extracted using a custom interface cable and inserted into a time series database with a graphical front end for fast analysis of the entire deployment or comparison between arrays on similar deployments. Data export to standard formats provides for additional analysis in the existing toolchains of choice. At the time of this recording, the Vista system has successfully been through hardware-in-the-loop testing to prove out the major design choices. The circuitry has been built into a functional prototype, and initial lab testing has been completed in preparation for final packaging and in-water testing by the Navy, which is expected to commence in the first half of fiscal year 2023. Once the initial packaging and in-water testing is complete, Vista will undergo handler testing in preparation for a full deployment on an operational towed array. The safety and approvals package is currently submitted and expected to be approved in early 2023 for operational testing. With no currently fielded competing technologies, Vista provides a number of unique advantages and benefits. First and foremost, Vista provides a glimpse into the operational environment the array has been deployed into over time. This environment consists of a number of forces and conditions that have material impacts on the array's construction and electronics, which to this point have only been collected in test scenarios, not in a real-world deployment. Second, Vista provides an opportunity to perform root cause analysis on towed array failures by looking at the major forces impacting the system in the hours or days leading up to the failure. Identifying significant events and environmental changes provides tracking mechanisms. Third, the onboard data synthesis and off-platform graphical analysis provide a fast review of the data over the course of a deployment for the engineers working onshore to determine the future test plans and requirements for arrays to ensure that they are meeting what is experienced in the real world. Finally, Vista helps protect the Navy's investment in a critical sensor for the fleet by creating a path to condition-based maintenance for operational arrays deployed in the fleet on either submarines or tow ships. Once testing is completed, Vista is expected to transition to a thin-line towed array during fiscal year 2023 and 2024. The outproduct of the thin-line testing will be used to refine the design and adapt to the requirements for a fat-line array, as well as add additional sensors to the Vista system. In addition to the thin line and fat line array needs, Vista can provide value to other underwater use cases such as unmanned underwater vehicles and remotely operated vehicles used across the Navy, the arrays used for oil and gas exploration, and other uniquely adverse environments such as underwater, those with hazardous air quality, or in a vacuum. Integration into the thin-line towed array program of record will follow two paths. First, Vista will be inserted into currently fielded arrays through direct sales to the government. These systems will be integrated during depot retrofit as part of the preparation for the next deployment cycle. For new arrays, Vista will be inserted through the existing prime contractor as an additional capability to add the module to the future arrays as they are delivered from the factory. Trident is actively seeking additional programs and platforms of record that would benefit from the Vista capabilities. To find out more, you can visit us at West 2023 in Trident's booth 2302, right by the main entrance. We'd love to tell you more about Vista or our other world-class products. If you cannot make it to West, please reach out to me at edward.bauman@tridsys.com. We'd love to help you with your health monitoring needs. Thank you and have a great day.